So for our last review this week, let's just start by solving everything for y. Okay. So there's not a lot of room right underneath the problems. You might need to rewrite them just to have space. Unfortunately, the most common mistake here is really not knowing how to do it. It's more about you're writing it in some, trying to cram all the work in some small space so you can't see a negative. So your whole graph is going the wrong direction because of organization, not because of math. So do yourself a favor, rewrite it so you can actually see it, and there'll be fewer mistakes with your printing and fewer mistakes on your answers as well. So take the time to show everything, as those that are usually in a big hurry are the ones that make the most mistakes. Regardless of how much math you think you know or you can do, it's just being in a big hurry will mess everything up. So write everything out. Check it twice as you're doing it. That way you can do the problem one time and be done. No restarts, right? So same things we've been doing all week. You're always going to try to get y by itself. That means we need to get rid of a -6 by adding 6. Get rid of a -3 by dividing by -3. So if it has a variable with it, you're dividing. Otherwise, you add, subtract it. Always starting with adding, subtracting first. Right? So this should look familiar. And then simplify the double negatives and the fraction. So let's go to graph it, starting at the last number here, -2, right? And then we're going to go up to and right to. Up to, right to. And we can always reverse it and instead go down and left. That will line up on the same straight line. Okay. All of these are solid lines since these are equations. We're not into the solid dotted part that comes with inequalities only. So that's it. Try to get as close as you can to your points, of course. Your answer is going to be where these intersect. So if your lines aren't perfectly straight, then they may not intersect in the right place. So our answer is not the graph, it's the intersection of the graph. There. A little bit better. All right. One more. So as you can see, these are somewhat time consuming, but not necessarily difficult. It's hard work, but it does take a little bit of time. Like before, everything this week, you know, we pull up decimals.com and type in the equations and verify it does match your answer as well. But then by the end of it, you want to make sure, hey, you can probably do it on your own without any help checking them. So this one variable is on the other side, so same idea but different, right? We have first the variable on the left here. You know, the y is on the left, here the y is on the right. Here it was a -6, so I added 6. Here it's the 21x. So I'm still trying to get everything away from the y. Start by adding the 21x, and then I'm going to divide by the 9. Very similar steps, but yet it is different. Like a rhyme. Not going to be exactly the same problem by problem, but it will be similar. Dividing everything out is probably your best bet. 5 by the 9. All right. So we have 21 over 9. Probably want to reduce that. Divide top 1 by what? 3? Yeah. 3? 3 goes into 21 7 times. 3 goes into 9 3 times. Yeah, otherwise we wouldn't really be able to graph that slope if we had to go up 21 and over 9. This does not cover it. Plus 3 and equals 1. We'll start at 3. And we can't go up 7 over 3. Look how like here we went up 2 over 3, but you can also go down 2 and left 3. So that's what we're going to need to do. Since we can't go up and right, we're going to go down 7 and left 3. Like right there. So, am I done with this problem? Yeah, one little issue. I haven't written the answer yet, right? So we got to write the answer, which is where they intersect in coordinate form. So this is -3, -4. X, Y. Question? Yes, but we can't go up 7 over 3. That takes us off the graph. So we're going to go down this way. It's still a positive line because it's going up. So this is positive. But we just can't fit it on the universal. And we're allowed to do that because 7 over 3 is the same as -7 over -3. These are equal to each other, right? So that's why we can either go positive and positive, or we can go down and left, and it's the same line. It works either way. Oh, I just found there's the x, right, on the x-axis, and this is the y. The y-axis is where they intersect. So two lines intersect. So a little bit of work. Use decimals as needed to check, and then after a while you'll get the hang of it. This is all review, so counting on a lot of prior knowledge of you knowing things about how to solve for x, how to solve for y, and get the slopes and things like that. Do you guys want to do another example, or you just want to try and start working? Number 2? Number 2 is a little bit of an oddball problem, but it's not that far from being solved. So it might start off looking a little different, but all right, let's start by, we need to get this by itself. So let's go ahead and subtract x on both sides. I'm going to rewrite it over here. And normally we divide by whatever's in front of y, but since this is a fraction, we usually never divide by a fraction, so multiply by its reciprocal. And you have to multiply this entire side right here by the same number. We got 0, we got 1, cancel out the 1, got y equals. Then we can just distribute. Five fourths times x is just 5/4 x with the negative. And then we got 5/4 times 4/5. Kind of like the same thing we have right here. They're reciprocals. You're multiplying reciprocals together, so they're going to equal 1 with a negative. Because the 5 will cancel with this 5 down here, and the 4 will cancel with this 4 up here. So it actually works out pretty nice. Start at -1. And it says down 5 over 4. But once again, we can't go down 5. That takes us off. So think of the negative as being on the bottom. So we have to go up 5 and left 4. Up 5 and left 4. Okay, so start by adding 4 to both sides, and then you divide both sides by -4. So it's a little cleaner than the last. You know what the answer is? There is no answer. Oh, maybe there is. Let's see here. Wow. Doesn't that look strikingly familiar? Look at the first one, and look at this one. That's the same exact one. So the answer is where these intersect, right? And so what do you say if they intersect every single point? Oh, there's an infinite number of intersections, so we call it infinite solutions. If they didn't intersect at all, they're parallel, then there's no intersections, it would be no solution at all. I'll leave you that. Now, let's go ahead and graph these. They're already in self-intercept form, so it's going to be a little bit easier to graph. Your focus is more on the shape. Now, what you might want to do is from the very beginning is mark which one's solid, which one's dotted. If you have that ahead of time, you're not going to, well, less likely to miss it later on. So we're going to start at 1, positive, up 1 over 2. You can also reverse it, goes down, and left 2. And then use your dashes in between. So it's really detail oriented. Skill-wise, it's very simple because it's already solved for y. Start at -2 here, and this is positive 2 over 1, so up 2 over 1. And these may not intersect at an exact line, exact point. They do here, they intersect right here, but that's not the answer. It's different from the other ones we've been doing. The answer is actually where the shading overlaps, not where the lines overlap. And once you intersect these two, like most of them, it'll make 4 different areas. So here's an area of shading. This one's an area of shading right here. This is another area right here. And this is a 4th area. I always usually make four different areas that can be shaded. One of them is the correct one. So you need to find which of these 4 is going to be less than for both. So it has to be both below the red line, the dashed, and below the blue line. So which area is below both? 1, 2, 3, or 4. Here in 3, right? So if you go straight below the blue, it's this area, and straight below the red, it's this area as well. 4 is going to be above the blue, right, but below the red. 1 is above both, and 2 is kind of like the opposite of 4. It's above the red, but below the blue. So that's the little decision you have to make for each of these. Seeing which of those 4 regions is actually fits the 2 inequality signs. In general, when they're both facing the same direction, it's a little bit easier. You can kind of see which one's above both, which one's below both. But with their 1 and 1, like number 12, have 1 above, 1 below, you just have to be a little more careful there. Let's take a look there. Again, this is going to be dashed. This is going to be solid. Mark that ahead of time so you know you should have 1 dash, 1 solid. That's not going to be a problem later on. Start at -2. And this is a -1 right here. So if the negative's in the front, think of it as being up here with the top number. So we want to go down 1 over 2. Down 1 over 2. And put dashes between. and then start at positive 2, and then up 3, right 2. So we want to be, let's see here, above the blue line. This is greater than, right? So we want to be above the blue line, but below the pink line. So which of the areas, I'll remember them again, 1, 2, 3, and 4, which one would be above the blue, but below the pink? Yeah, 2. There's blue above it, and then pink below it. That's the area 2. There we go. All right, so I think that'd be a good start for you. Get you started on these, and remember, due by the end of class